Red, not orange, not yellow, red. The USGS Hawaiian Volcano Observatory just changed Kilauea's alert level to the highest color in the entire volcanic alert system. And here's the thing about red that no mainstream coverage explains correctly. Red is not a warning. Red is a confirmation. By the time the color changes to red, by the time that bulletin goes out, the eruption has already begun. Or it is beginning at this exact moment. Red does not say, brace yourself. Red says, it's happening, right now. And the lava fountains that follow a red declaration at Kilauea's summit, the ones visible on webcams across the island, are not hours away in the way that a storm is hours away. They are hours away in the way that a door already opening will be fully open in hours. The process has started. The color just told you so. Here's what this video covers. The USGS volcanic alert level system has 4 colors: green, yellow, orange, red. Most volcanoes live in green or yellow. Elevated unrest earns orange. Red is reserved for one specific condition: eruption underway with potential for significant ash emission or other hazards requiring immediate action. That condition exists at Kilauea right now. But here's the detail that separates this red declaration from the ones before it. This is not the first time Kilauea has gone red in the current eruption cycle. It has been red before, multiple times. And each time, the eruption that followed was contained within the caldera. Photogenic, safe for observers, resolved within days or weeks. So why is this red different? Because the signal stack that preceded this declaration is not the same signal stack that preceded the others. The inflation rate was higher. The deep seismicity was more sustained. The SO2 reached levels not recorded before a summit eruption since 2018. And 2018 was not a summit eruption. 2018 was the eruption that consumed 723 homes. The scientists at the HVO who changed that color this morning are not the same scientists who changed it before previous episodes. They have more data, more pattern recognition, more comparison points, and they changed the color faster than they did before. That speed, that compressed timeline from elevated unrest to red, is the detail no bulletin headline captures. Stay with me. Because red at Kilauea is not the end of the story. It is the moment the story stops being about data and starts being about what is already in the air. The USGS Volcano Hazards Program operates 2 parallel alert systems for every volcano it monitors. Most people know about one of them. The volcanic alert level, green through red, designed for ground level hazards, lava flows, pyroclastic events, volcanic gases, lahars. This is the system that just moved to red. What almost no mainstream coverage explains is the second system that moves simultaneously with the first. The Aviation Color Code, also green through red, designed specifically for pilots and air traffic control, tracking volcanic ash that threatens aircraft engines. When Kilauea's ground alert level moves to red, the Aviation Color Code moves to red at the same time. 2 separate red declarations, 2 separate audiences, 2 separate sets of consequences. The ground red triggers national park access protocols. Visitor management, emergency response staging. The aviation red triggers notifications to the FAA, to every airline operating over Hawaiian airspace, to the Honolulu Air Route Traffic Control Center, and to the Pacific VAAC, the Volcanic Ash Advisory Center that monitors ash clouds across the Central Pacific. 2 reds, 1 volcano, 1 morning. And here is what the aviation red means in practice that most viewers never consider. Kilauea sits on the big island of Hawaii, an island whose primary airport, Hilo International, sits 40 kilometers from the summit. Kona International Airport sits on the other side of the island. Both airports serve an island that has no road access to the mainland. If volcanic ash from a significant eruption forces both airports to close, the Big Island has no surface evacuation route off the island. None. Residents who cannot evacuate by air cannot evacuate at all. The Aviation Color Code RED is not just about airlines and routing decisions and flight path adjustments. It is about whether an island of 200,000 people retains access to the rest of the world. That is what RED means in its fullest dimension. And it is in force right now. Alert levels do not change because a scientist decides the situation feels serious. They change when specific thresholds, defined in the HVO's monitoring and response protocols, are crossed. For Kilauea's ground alert to move to red, at least one of 2 conditions must be met. Either eruption has begun, or eruption is considered imminent based on precursory data that has crossed the established threshold for near-term activity. This morning, both conditions were approaching simultaneously. The eruption had not broken the surface when the red was declared, but the seismic signature beneath the crater, the upward migration of earthquakes into the shallowest part of the system, the zone within the top kilometer beneath the crater floor, crossed the pre-eruptive threshold that the HVO has now documented across enough eruption episodes to treat as a reliable indicator. Not a perfect predictor, not a guarantee. A reliable indicator. The distinction matters. Reliable means it has been right more times than it has been wrong. It does not mean the eruption cannot stall or redirect or express itself differently than previous episodes. But it means that when that seismicity signature appears, when the earthquakes cluster in that specific shallowest zone, the HVO does not wait to see lava before changing the color. Because by the time you see lava, by the time the crater glow is visible on the webcam, the eruption is already underway. And the people who need time to make decisions, park visitors on access roads, tour operators with clients near the crater rim, airline dispatchers routing flights over the Big Island, those people do not benefit from a red alert that arrives after the lava does. The red alert is early warning disguised as late warning. It arrived before the lava. Barely. By design. The term lava fountain sounds decorative. It sounds like something you would see at a resort. Let's correct that. A lava fountain at Kilauea's summit is the surface expression of pressurized magma finding an opening through the fractured crater floor and erupting upward because the pressure driving it is greater than the weight of rock and atmosphere above it. The height of the fountain is a direct function of that pressure differential. In routine, Kilauea summit eruptions over the recent cycle, December 2020 through 2023, fountain heights ranged from a few meters to occasional bursts of 50 to 70 meters, significant, visible from the crater rim overlooks, not structurally threatening to observers at designated distances. But Kilauea's fountaining history does not stop there. In 1959, Kilauea Ekai crater, adjacent to the main summit caldera, produced fountains that reached 580 meters. 580 meters, nearly twice the height of the Empire State Building, from a crater floor, shooting upward. That 1959 event was not a caldera eruption. It was a vent in a smaller adjacent crater. It produced lava fountains that were visible from Hilo, from 40 kilometers away. The lava that accumulated in Kilauea Iki during that eruption was 135 meters deep. It took 35 years to fully solidify. Scientists were still measuring its cooling rate into the 1990s. The current eruption onset, the one that RED is signaling, is not expected to reach 1959 levels. The summit system's current volume and pressure state is not consistent with a 580-meter fountain event. But the physics that produced 1959 and the physics producing this morning's signal are the same physics. Pressurized magma, an opening in the crust, the force of what is behind it. The difference is magnitude, not mechanism. And magnitude at Kilauea has surprised scientists before. Here is the historical anchor that makes this RED declaration read differently. From January 3rd, 1983 to June 27th, 2018, Kilauea erupted continuously. Not intermittently, not episodically. Continuously. For 35 years, 5 months, and 24 days, the eruption was centered on an event called Pu'u'o'o on the East Rift Zone. It produced more than 4 cubic kilometers of lava. It added 875 acres of new land to the Big Island coastline. It destroyed 189 homes. It buried the town of Kalapana under 25 meters of lava. It paved over Highway 130 multiple times. It closed Chain of Craters Road permanently in some sections, under lava fields that are now tourist attractions. For 35 years, it never stopped. Until it did. In April and May 2018, the Pu'u'o'o vent collapsed. The lava that had been feeding that continuous 35-year eruption had to go somewhere. It went to the lower East Rift Zone. It opened 24 fissures in residential Puna. It destroyed 723 homes. It buried Kapoho Bay. It erased vacation land, and then it stopped. The entire Pu'u'o'o eruption, 35 years of continuous lava output, ended in September 2018, completely. For the first time in 35 years, Kilauea was not erupting anywhere. That silence lasted until December 2020. When the summit eruption cycle began, the one that is currently at red alert. The detail that every volcanologist carries when thinking about today's red alert is that the 35-year eruption did not look like what it was until it ended. It looked manageable. It looked contained. It looked like Kilauea doing what Kilauea does, until the vent collapsed and the system found a different answer to the same pressure. The red alert today is for a summit eruption. The question that no bulletin addresses directly, but that every volcanologist with a memory of 2018 carries implicitly, is whether a summit eruption is the only answer the system is currently considering. The HVO's real-time monitoring during a red alert event operates at a different tempo than normal operations. Instrument checks that happen every hour on routine days happen every few minutes. Webcam footage is reviewed continuously, not by automated systems alone, but by scientists watching for the first visual signal of eruption onset. The specific signals they are watching for right now in the minutes between the red declaration and the first lava appearance: tremor amplitude. When magma moves through the final meters of rock before reaching the surface, it produces a specific seismic signal called harmonic tremor, a sustained rhythmic vibration that is distinct from individual earthquakes. The HVO seismic network filters for this signal continuously. When harmonic tremor appears in the seismograms, strong and sustained, eruption is not minutes away. It is underway. Ground tilt. The tilt meter network at the summit will record a specific signature as eruption begins, a rapid deflation as magma leaves the reservoir and reaches the surface. This deflation happens in real time. It is not a lagging indicator. When the tilt meters show a sharp drop, simultaneous across multiple summit stations, lava is exiting the reservoir, crater glow. The infrared cameras and standard webcams positioned around Halema Uma'u will show the first sign of incandescence before visible light reaches an observer at the crater rim. The HVO monitors these cameras frame by frame during red alert conditions. The first glow, the first pixel of incandescence in the crater floor, will appear in the camera feed before any human standing at the observation deck can see it. And when it appears, the pixel will trigger a cascade of notifications, updates, and bulletins that move faster than any news cycle. That pixel has not appeared yet. The cameras are running. The scientists are watching the cameras. The magma beneath the cameras is ascending. Hawaii Volcanoes National Park does not close when the alert goes to red. Not automatically, not immediately. The Park Service evaluates conditions and makes access decisions based on real-time hazard assessment, not the alert level alone. During previous red events in the current eruption cycle, the summit overlooks remained open as the eruption began, because the eruptions were effusive, contained within the caldera, and visible safely from designated viewpoints at the crater rim. That policy produced some of the most viewed volcanic footage in internet history. It also produced crowds of thousands of people on access roads designed for scenic touring, simultaneously with SO2 concentration levels that required masks, wind direction awareness, and periodic voluntary withdrawals from the most exposed overlooks. Right now, in the hours before lava appears, there are people in the park. There are always people in the park. On any average day, Hawaii Volcanoes National Park hosts between 3,000 and 8,000 visitors. During a red alert event, when the eruption is expected to begin and the park remains accessible, that number does not decrease. It increases. People drive toward it, from Hilo, from Kona, from resort hotels on the Kohala coast 2 hours away. Rental cars fill the parking areas at the Jagger Museum overlook, at the Kilauea overlook, at the Chain of Craters road turnoffs. The red alert is paradoxically a tourism signal as much as a hazard signal. The Park Service knows this. The rangers managing the access roads know this. They are currently managing the tension between two legitimate realities. The eruption that is coming is, based on pattern, likely to be viewable safely from designated overlooks. And the eruption that is coming could also be something else. Managing that tension, in real time, with thousands of people already on the roads, is the operational challenge that no bulletin describes. Start at the crater. Eruption onset. First fissure in the crater floor. Lava appears. SO2 spikes immediately, from elevated pre-eruptive levels to full eruption output. The HVO updates its bulletin. Aviation color code confirmed red. The Pacific VAAC issues an ash cloud advisory for the airspace above the Big Island. Move outward. Hilo International Airport, 40 kilometers from the summit, activates its volcanic ash protocol, runway inspection, wind direction assessment. Aircraft on the ground evaluated for ash exposure risk. Hawaiian Airlines, United, Alaska Airlines, all operating Big Island routes, receive SIGMET notices. Significant meteorological information. The aviation system's highest priority weather advisory. Move outward. The SO2 plume, not ash but sulfur dioxide gas, moves downwind from the summit. Depending on wind direction, communities in Kau, in Kona, or in Hilo receive volcanic air quality advisories. The Hawaii State Department of Health activates its VOG advisory system. School outdoor activities in affected areas are suspended. People with respiratory conditions are advised to stay indoors, move outward. Kilauea's eruption generates media coverage that reaches globally within hours of the first webcam image. The Big Island's hotel occupancy, already elevated from visitors who came for eruption viewing, spikes further as bookings from the mainland and Japan accelerate. Airlines add capacity. Charter operators activate volcano viewing tours. The Big Island's tourism infrastructure responds to a red alert the way a theater responds to a sold-out performance. Every seat fills. Move outward one final time. The scientific community responds to a Kilauea eruption the way a research institution responds to a once-in-a-cycle opportunity. USGS scientists not on shift report to the HVO. University of Hawaii volcanologists activate field sampling protocols. Drones equipped with gas sensors and thermal cameras are prepped for deployment. Lava samples, collected in the first hours of a new eruption episode, provide data about the composition of the magma batch currently driving the system. That composition data tells scientists whether the magma reaching the surface now is residual material from the previous episode, or a fresh batch from deeper in the system. Fresh batches carry different volatile content, different pressure potential, different eruption duration estimates. The first sample from this eruption will be analyzed within hours. What it shows will tell scientists whether this episode runs for days or months. There's a version of this eruption that Hawaii has already rehearsed, multiple times. The summit eruption that opens in Halema Uma'u, the lava lake that reforms, the fountains that build within the caldera walls, the gases that require monitoring, the crowds that come to watch. The webcam footage that goes viral, that version is in the Park Service playbook, in the HVO response protocol, in the hotel industry's contingency pricing model, in every news outlet's volcano footage archive. Hawaii knows how to handle that eruption. It has done it 6 times in the current cycle. The eruption nobody in Hawaii has written a full playbook for, the one that exists in historical memory but not in living institutional practice, is the eruption that does not stay at the summit. In 35 years of Pu'u'o'o eruption, 1983 to 2018, Hawaii developed infrastructure, communities, and economic assumptions around a volcanic landscape that was continuously active on the East Rift Zone. People lived adjacent to it, businesses operated near it, roads were rebuilt around it. An entire regional culture developed its relationship to Kilauea based on where it was erupting for those 35 years. And then in May 2018, in less than 4 months, that landscape was rewritten. 723 homes, Kapaho Bay, Vacation Land, Highway 130, Green Mountain, all of it gone. Not because anyone did anything wrong, not because the monitoring failed, not because evacuation orders were not issued, because the system made a different decision than it had made for 35 continuous years. Today's red alert is for a summit eruption. The playbook for a summit eruption is ready. What the red alert cannot tell you, what no monitoring data currently indicates but also cannot rule out, is whether this eruption is an episode in the summit cycle, or whether it is the beginning of something the playbook does not yet cover. There are 3 ways to read red alert at Kilauea this morning. The eruption opens in Halema Uma'u, lava fountains within the caldera. The episode runs consistent with recent pattern. Days to weeks of activity, contained, monitored, safe to observe from designated park overlooks. SO2 advisories are issued, aviation protocols activate briefly, the lava lake reforms. Then the episode ends, the color returns to orange. Scientists collect samples and prepare for the next cycle. This is the most probable outcome. It is what the recent pattern most consistently predicts. Its strength? It has happened 6 times in this cycle. Its weakness? The signal stack preceding this red declaration was more compressed and more intense than any previous episode onset in the current cycle. More intense pre-eruptive data does not necessarily mean a more intense eruption, but it is a variable that scientists are not discounting. The fresh magma batch currently ascending to the surface, indicated by the sustained deep seismicity of the preceding week, has higher volatile content than the residual material that drove recent shorter episodes. Higher volatile content means more gas. More gas means more explosive energy in the fountain dynamics. The eruption is still effusive. It is still contained within the caldera. But the fountains are higher. The SO2 output is greater. The aviation advisory footprint extends further. And the episode runs not for days, but for weeks or months. A sustained energetic summit eruption changes the operational calculus for the Park Service, for airlines routing over the island, for residents of Hilo and Kona managing chronic VOG exposure. It is not catastrophic. It is not the 2018 scenario. But it is a different quality of event than Hawaii has managed in the current cycle, and it would be the most energetic summit eruption at Kilauea since the sustained activity that preceded the 2018 rift eruption. This is the interpretation that lives in the back of every HVO scientist's awareness during a red declaration, present without being voiced, real without being probable, impossible to eliminate without more data than currently exists. The summit eruption begins. It draws on the fresh magma batch at rates that depressurize the shallow reservoir faster than normal. The deep supply system responds by increasing input. The increased input pressurizes not just the summit, but the full conduit system, including the Upper East Rift Zone, which has shown elevated inflation in GPS deformation data for the past several months. A dike propagates into the rift, not confirmed, not indicated by current seismicity, but not foreclosed by any data point currently in the monitoring record. And if it happens, if the rift reactivates while the summit is erupting, the decision window for communities in Puna is not measured in days. It is measured in hours, the same hours that are currently unfolding between the red declaration and first lava appearance. The HVO bulletin that accompanied the red declaration is 3 paragraphs. It describes current conditions. It references the alert level change. It advises that the public follow guidance from Hawaii County Civil Defense and the National Park Service. It does not say The 7-day signal buildup that preceded this declaration was the most sustained pre-eruptive sequence in the current eruption cycle. It does not say the deep seismicity component of that sequence is more consistent with fresh magmatic input than with residual reservoir repressurization. It does not say the GPS deformation data in the Upper East Rift Zone has been above baseline for 3 months. Not dramatically, not at levels that justify a Rift Zone alert, but measurably. It does not say any of those things. Because a 3-paragraph bulletin designed to communicate hazard status to a general public is not the place for geological nuance. The bulletin communicates what people need to know to make immediate decisions. The nuance lives in the data, in the monitoring record, in the conversations between scientists who are looking at all 3 facts, the sustained signal, the fresh magma indicators, the elevated rift deformation, and asking the question that no bulletin asks publicly: which eruption is this? The one in the playbook, or the one that rewrites it? That question is not answered by the RED declaration. The RED declaration is the moment the question becomes urgent. Here is what the RED declaration confirms. The eruption has begun, or is beginning. The magma is at or near the surface. The hazards are real and present. Here's what the RED declaration cannot tell you: how long this episode runs. Whether the magma reaching the surface now is the residual material of the previous cycle, which would suggest a shorter, lower energy episode, or a fresh batch from depth, which would suggest longer duration, higher energy, and the possibility of system behaviors not seen in the current cycle. Whether the elevated GPS signal in the Upper East Rift Zone is a passive response to summit pressurization, the system inflating symmetrically as magma rises, or whether it reflects independent pressurization in the rift itself, a condition that could express independently of the summit eruption that is happening right now. Whether the summit eruption draws pressure away from the rift, the most common outcome, or feeds pressure into it, the less common outcome that occurred in 2018. These unknowns are not gaps in the monitoring record. They are the questions that the monitoring record generates, but cannot currently resolve. Because the answers live in the composition of the magma batch now ascending to the surface, data that will not exist until a sample is collected, and in the stress state of the rift system, data that will only become clear as the eruption evolves over the next hours and days. The red alert is the most certain thing USGS can say. Everything else, duration, energy, rift involvement, is the cloud of uncertainty surrounding a certainty. The eruption is happening. What kind of eruption it is still being written in the rock, in the lava, in the data that the instruments produce 1 second at a time. Let's go back to the crater. Halema Uma'u, before dawn. The cameras are running. The crater floor is a black expanse. Cooled lava from the last episode, fractured in places where the ground has settled over the empty space below. Steam vents along the crater walls produce thin white columns that the wind tears apart immediately. The infrared camera in the HVO monitoring array is reading temperature gradients across the crater floor, looking for the signature of magma within its detection range of the surface. And then, in the infrared feed, before any visible light, before any webcam captures it, before any observer standing at the crater rim can see anything, a thermal anomaly appears, a spot on the crater floor warmer than the rock around it, then brighter, then a crack, visible now in standard camera, a line of incandescence opening in the dark surface. Lava. The first lava of this eruption episode. The seismograph records the harmonic tremor that started 30 seconds before the crack opened. The tilt meter records the deflation that started 20 seconds before. The SO2 sensor records the spike that starts the moment the crack opens. The HVO bulletin system generates an update automatically. The update goes out before a scientist has read it. The Park Service rangers at the access points receive the notification and begin their assessment of whether the overlooks remain accessible. Somewhere on the Volcano Highway, a car that left Hilo an hour ago, the driver who saw the red alert and drove toward it, is 12 minutes from the park entrance. They will arrive to a different mountain than the one they drove toward. Not more dangerous, necessarily, not less beautiful, different. The crater that was dark an hour ago is now producing light. The light comes from 4 kilometers below the surface where it started weeks ago, or months ago, or years ago, when the magma that is surfacing right now first began its ascent through the rock above the Hawaiian hotspot. It has taken that magma a geologically instantaneous and humanly incomprehensible amount of time to travel from the mantle to this crack in this crater floor on this morning. The red alert was issued 90 minutes before the crack opened. The magma has been traveling for longer than that, longer than the current eruption cycle, longer than the 35-year Pu'u eruption, longer than any human institution that has ever issued a bulletin about it. It arrives now, at this crack, in this crater, on this morning, not because today was scheduled, because today is when the pressure finally exceeded the weight of everything above it. The lava is visible on the webcam now. The fountains are beginning to build. The color on the USGS bulletin is still red. It will stay red until the scientists watching the data determine that the hazard has changed. They are not making that determination yet. They are watching the fountains build, measuring their height, measuring the SO2, measuring the tremor, measuring the tilt, measuring everything except the one thing that cannot be measured until it is already over. What kind of eruption red turned out to mean this time? The lava does not know the question. It is just doing what it has been doing since it left the mantle, rising.